Well, hello, members of seventh grade. Happy Phrase Day. Today we're going to look at proportional and non-proportional relationships, something that your book has been very interested and keen in you coming to understanding. And today we're mostly going to answer proportional questions, but we'll also talk about linear and things like that. So L88, year of my graduation from high school, proportional and non-proportional relationships. And go ahead and start by drawing these three graphs. Obviously, they're all first quadrant, and they mirror certain relationships. And the question is, which one of these is, or are all of them proportional? Now, things to remember about proportional is this, that proportional must be two things. It must be linear, and it must go through the origin. And I know we've explored those ideas before. So if we look at the first example, would that be considered linear? Clearly linear. However, it does not go through through the origin. Therefore, if we ask whether these things are proportional or not, which is the big question of the day, we'd have to say, no, this one is not. If we look at the second one, would that be considered linear? It sure would. And also, does it go through the origin? It sure does. So this would get the big yes. If we look at this last one, and you may have been seeing this if you're following the COVID, this is called exponential growth. And though it goes through the origin, is clearly not considered linear. And this would be a no. Yeah? So kind of just to start us off thinking, looking, if we can look at things and determine whether they're proportional, we'd want to look for those things, linear and through the origin. Here we have some squares, and we're going to look at maybe the first square as the first one, and then we're going to kind of consider scale factor. So the first one would have a scale factor of just 1. And then we're going to dilate this square, if you will. And so with a scale factor of 1.5, then we would see that that side length would now be 3. And then a scale factor of 2 would have a side length of 4. And then this last one would be a scale factor of 2.5. And that would give us 5. And I want to explore, for side length, I want to explore two things, perimeter and area. And we've actually looked at these ideas before. But if we were going to make a chart with perimeter, like an input-output chart, with side length being the input, and perimeter the output, and the same for area, side length and area being the output, if we had a side length of 2, as we do, clearly P equals 4S, so therefore our perimeter would be 8, right? Side length of 3, perimeter would be 12. Side length of 4, perimeter would be 16. Side length of 5, our perimeter would be 20. Now, when we go and consider area, if we had these same side lengths, well, we're not going to get the same values, obviously, because it's area. Area is equal to S squared, side squared. So our first area, our first output would be clearly 4. And then we would have 9 for 3, and then 16, and then 25. It used to always blow me away how the 4 perimeter was the same for perimeter and area out at 16. Um, so then the question would be, well, are these proportional? And if you looked at the first situation, we could test through cross products, right? If we said 2 is to 8 as 3 is to 12, or as 4 is to 16, as 5 is 20. Well, these all actually reduce to one fraction only, which would be 1/4. So you'd have to say for perimeter, yes, these are proportional. However, we could not make a proportion for the area, at least one that wouldn't hold all the way forward. So could I say 2 is to 4 as 3 is to 9? Oh, no, that's not true. How about 3 is to 9 as 4 is to 16? That's not true. 4 is to 16 is 525. None of these are proportional, and therefore I'd have to say no, that's not true, right? Well, it's not that it's not true, it's just not proportional. It wouldn't, it might be linear, but it wouldn't go through the origin. But is it linear? It's interesting to think about. But we could simply say yes and no for proportional. Hey, let's look at this idea. So we've talked about similar triangles before. Remember, similar triangles are going to have obviously congruent angles, and we always say that their sides are in proportion. So if we name the base and height of similar triangles, a base of 2, a height of 3, And then a similar triangle would be a base of 3 and a height of 4.5. So this is all true information for similar triangles. Now, here's the thing, though. What if I asked you to predict what the height would be with a base of 15? So if the base was 15, so let's put 15 in that column, how could we go about determining that height? Well, remember the key is that similar triangles are proportional. So if they're proportional, then I can create a proportion. And I could use any of these, this 2, 3, this 3, 4.5, this 4, 6, or the 5, 7.5. I'm just going to go with using the 2, 3. And I'm going to make a proportion stating 2 is to 3 as, now remember the 15 is my base, so I have to connect it with the 2, as 15 is to, and let's say h. And then are you guys ready? I am. And then 2h, I'm going to do the multiplication because there's no cross canceling for me. So we'll say 45, and then we isolate through division. I divide both sides by 2. And then I say h is equal to, they seemingly want a decimal form, so I'll say 22.5. And therefore my height is 22.5. And I was able to figure that out because of the proportional nature of similar triangles. Dos Mas, you're going to need a cover-up tool, not for this next one, but soon. So if you don't have one, just pause one, go grab a cover-up tool because you're going to need it, but not for this next one. So let's look at this. They're asking us to look at 3 equations or formulas and name whether they're proportional. So we have A, C is equal to pi d. You should know what that is, circumference of a circle. B, A is equal to pi r squared. You should know what that is. That is area of a circle. And then the last one, C is equal to y equals 2x plus 1, which is just a standard linear equation. So if we think about proportional, one thing I want to remind you is that we actually have a formula for this, and it's called something. Anyone? Yes, for the sticker, direct variation. Good remembering there. And we actually have a formula for direct variation is y equals kx. And we've explored these ideas before. So we can basically look at formulas and go, does it fit this y equals kx form? Does C equals pi d fit y equals kx? Does A equals pi r squared fit y equals kx? Does y equals 2x plus 1 fit y equals kx? Well, you should be able to determine that only one of them does. This is a yes. That is proportional, right? And then the B would be a no because we've got that squaring happening. And then this one is linear. However, it's not proportional because we see the presence of that plus 1, which is not part of direct variation. All right, last one. This is where you need a cover up tool. And basically, I just need you to cover up the top part of 589 because that's where they give you the answer. So you probably don't need a cover up tool. Just don't look at page 589. And we're going to consider these problems. You don't need to write this in your notes. I just want you to think about it. So they want to know which of these can be solved with proportional thinking. A, which says it takes 2 workers 5 hours to complete the job. I know you can read 2. How long would it take 4 workers to complete the job? Yeah, okay, possibly. B, the shipping charge is $2 per item plus a $3 flat fee, so it costs $13 to ship 5 items. What is the shipping charge on 10 items? And then letter C, each student read the same number of books. 30 students read a combined total of 150 books. How many books were read by 60 students? And if you think about all of those, which one would be proportional? Which one fits into y equals kx? So I want you to think. I'll give you a moment. And I want you to commit to a choice. Pause me if you haven't yet. All right, so you've unpaused me. Thank you for coming back. Which one did you choose? Did you choose A? Did you choose B? Or did you choose C? Yeah? All right, good. I'm glad to hear that all of you chose C. And this is true. Now, the whole workers thing, the more workers I throw into this situation is not going to increase the hours. It actually will lessen the hours. Therefore, that's not direct variation. It's something called inverse variation. For letter B, we see that there is this extra little fee per item sent. So that extra little fee is going to be that little plus 1 or plus whatever it is. Therefore, it's going to be linear. However, it's not going to be proportional. And then the last one is they say the students read the same number of books. So we're just extrapolating out in a proportional manner. Yeah. So that's about it for lesson 88. Remember, this is Freya's day. So, well, it's not really Freya's day for me, but it will be for you. So we won't do any homework, but we'll assign the split. So L88, hope you're doing well. Again, you can reach out to me at any time. Bye.